spring break is over, okay? You've sprung forward. You lost that hour of sleep. You spent a whole week maybe going to bed later than you should have. Well, maybe you always do, whatever, okay? No matter what, we are back, and so same expectations as usual. So, like, if you got headphones in your ears, on this row, please, please, please. While I'm talking, I like all of our ears to be open, okay? It is the fourth 9 weeks, which means it's like the fourth quarter. If you ever watch a game that has 4 quarters, unlike hockey, okay? But it's important to finish strong, okay? No matter what happened in the third 9 weeks, okay? You want to finish strong. Now, some of y'all, I'll talk to you about what your goal is. If you didn't pass, you got to have a higher goal to make it average out and pass for the whole semester. Whether you like me or not, I think most people want to move on from me and not take me next year, right? You'd like to go to the next teacher, hopefully. So again, my goal is to get you there, okay? I want you to achieve your own goals, get where you need to be. So again, if you just don't do what you're supposed to do this fourth 9 weeks, you might be here next year. I don't want that to happen to you, okay? So make sure you're working hard, finish strong, okay? Everyone wrote down this objective. Today we're going to talk about polygons, okay? And I got more cool songs that everyone loves to hear about polygons, okay? But first, I got a weird warm-up because today is a special day for all people that are mathematicians. Y'all are all mathematicians in your own little way, okay? You exposed yourself. All right, well, anyways, so pi. Have y'all heard of pi? I ain't talking about food, talking about the number. Y'all ever heard of this? Yeah? Okay. So pi is what we call an irrational number. It's irrational because the numbers go forever. There's no exact pattern to it. And if you've seen it before, it's right here. 3.14, 15, blah, blah, blah. Okay. Now, maybe in middle school they told you pi was 3. That's not correct. It's close to 3. Okay. But we usually say 3.14. And what's the date today? What? The 14th of the third month, 3/14. Hey, so today's Pi Day. That's the joke, okay? So today is 3/14, and we celebrate 3.14, 3/14 on Pi Day. Now, for some of y'all, that means you get a prize. Some of y'all. All right, so we'll see. But here, I took some ancient text, okay, to figure out how long ago we can find pi, okay? So this guy named Hiram made a large bowl. It's 10 cubits from one rim to the other. Now that's called, from one rim to the other, that's called the diameter, all the way across, straight across, okay? Now, y'all know what a cubit is? No? Okay, so check it out. Cubit, I think it's from your palm to your shoulder, cubit, okay? They didn't have like rulers, so they were like, all right, that's about 1 cubit, all right? So a cubit's about 18 inches. And then the other thing you're going to need to know is a hand's breadth, okay? If you look at your hand, this is the breadth, about 4 inches, hand's breadth, okay? Now, why does all that matter? Because back in the day, again, they couldn't pull out their big old rulers and protractors and stuff. They were just using parts of their body as measuring tools, okay? So it's almost like you got a ruler stuck on you. Now, so this guy named Hiram made a large bowl, 10 cubits all the way across, and then it says 30 cubits around it. Which, if you go around a circle, that's called the circumference. Okay, have y'all heard that word, circumference? Okay, so circumference is around the edge, diameter is all the way straight across. Now, pi isn't just some made-up loser mathematician was like, let me just think of a weird number. No, this is a natural number. It occurs in nature. Okay, so if you take any circle, if you measure around the edge and you divide it by straight across, you'll always get 3.1415, blah, 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 whatever, okay? So it's just a ratio or a fraction of the circumference divided by the diameter. So what you should have done on your warm-up, because I asked you to find pi using circumference divided by diameter. So look at these numbers, and I even tried to make it very obvious right here. What's the circumference again? 30. What's the diameter again? 10. So what do I do with 30 and 10? We divide it, right? So C over D. 30 over 10, what do I get? What's 30 divided by 10? Somebody, help me. 3, thank you so much. Now you tell me, is 3 pi? Not exact. Kind of close, right? 3 is in the ballpark, right? 3 is kind of close to 3.14, but it's not exact, okay? Now there's people with like wax in their ears, boogers in their nose, mocos, that are like get all bent out of shape. That means that this is whack. And this is wrong because this ain't right, okay? So we're gonna do a little bit of math. Here's what I didn't read. It was a hand's breadth thick, okay? So here's a little diagram on the bottom right. See the edge right here? Okay, that little thickness is 4 inches on each side, okay? Now, if I take all of these cubits, multiply them by 18, okay? I'm going to do a little bit of math below this. Now, this part you don't have to write down, just bear with me, okay? I'll show you something, in my opinion, that's kind of cool, okay? All right, so we're going to take that top part, okay? So 30 times 18. We're going to take those 30 cubits times 18. We get 540 on top, okay? On the bottom, though, the diameter, what we're going to do is we're going to take the diameter, which we said was 10 cubits, 10 times 18, but we're going to subtract, everyone look, 4 and 4, okay? 4 and 4. So we subtract a total of 8. Okay, now I could put this in the calculator, but I'm going to tell you what we got earlier. 3.139. Now you tell me, is 3.139 pretty darn close to 3.14? It is, okay? So all I'm here to tell you is even thousands and thousands of years ago, when they give you little measurements, you can actually turn it into inches today and do the tweaking with the calculations, and you can end up getting pi. Pi is timeless. It's old. It's found in nature. Anytime you see a circle, you see pi. So now look at this circle right here. Doesn't that look delicious? This oatmeal cream pie, right? Of course not, because no one says yes or no in this class. But anyways, wouldn't you like an oatmeal cream pie? Oh, really? Then you don't get one. Okay. But no, seriously. All right, to celebrate Pi Day, I thought I'd bring some pies, but guess what? Pies are kind of expensive, and there's like a lot of y'all. So I was like, okay, I'll get the oatmeal cream pies, but now I was like, wait, that's still a lot to give out. So I kind of narrowed it down. No offense to anyone, but I narrowed it down to my people. I wanted to reward the people that got an A in my class, who did the extra effort and did it. So I got 2 pies to give away for Pi Day. All right. I don't know if they're even here today. So Michael, not here. Okay, and okay. All right, there you go. You're the only one here that gets a pie. I mean, oatmeal cream pie. You know, if you don't like it, you can share it with someone. All right, thank you very much. Hey, you want one? All right, so that's it. Sorry, I don't have that many. So. Happy Pi Day. Now you know hopefully a little bit more about pi. Now, guess what? We're not doing circles, but it just so happened today is the day that I have to do this, right? So circles are going to come later in the year. Hopefully we don't run out of time. But today we're going to go, and we're going to talk about polygons, which have nothing to do with circles. All right, you like that? So here's a transition. Polygons are not round. They have straight sides. But, you know, I don't have a polygon day. I only have a pi day, so. So tonight, if you're thinking about what should I eat for dessert, and you got a pie in front of you maybe, just think about circles and math. Thank you. All right. Now let's think about these shapes, okay? Let me pull this up here. So you're looking at this page called What Are Polygons? Now, who can tell me, not a circle, but what's another shape that you know? Name a shape. Maybe you see it on this page, but what's a shape you know the name of? Rectangle. Okay, 4-sided figure. What else? What's a 3-sided figure? Say it. Triangle, okay? And then, so all these different figures, these are called polygons, okay? But there are things that are polygons and things that are not polygons. What I want to do is kind of put that on here. Put this side by side. Okay, cool. So here we go. What do you need to know about polygons? Okay, they are made up of straight line segments, no curves or round parts. So let's go ahead and start filling this in here on the left-hand side. Okay, polygons are shapes that have what again? Straight lines. Okay. Let me not spell that wrong. Straight lines. No, work. They don't have curves. Okay. So again, polygons, straight lines, no curves. What else? They are closed. I'll call them vertices. Vertices are the corners. They're closed. They're not open. Okay, so they don't have open vertices. Now you can see it on the right here. The ones in yellow, those are closed off. I mean, it'd be weird if it was just randomly opened up in one of the corners, right? I will also say it does not have overlap. There's no overlap when you see these, okay? I think that's about it. Okay, so at the bottom, let's look at the bottom and let's go ahead and try to, you tell me which one of these are not polygons. So looking at these, which ones are not straight, curved, open, overlapping, weird stuff. Okay, so help me out. Which one should I cross out? Yeah, on the left, it's like open, overlapping. That's weird. So everyone's Xing that one out. Let me also put up here 3 or more sides, right? I cannot think of a two-sided polygon because it would look like a straight line. Do you see that on here? So up at the top right, that straight line is not a polygon. You know, it's not open, it's not overlapping, but it's also, it has no inside. It's just a segment, okay? A segment is not a polygon. It has to be 3 or more sides. Cool? So again, that's what I added at the top there, 3 or more sides. All right, what else here should I cross out? And if you just got here, you got the paper? Okay. Okay, so give me a cross out or not. Cross out or no? Don't cross it out. Okay, what about the next one? Okay, cross this out because an oval has no corners, no straight lines. It's wrong. Okay, what about the one right below it? The one right below it is also curved, right? I don't know what that is. It's like a lopsided triangle or something. All right. What do y'all think? Is there anything else that's not straight lines, curvy? What do you think? What do you got? Got any more? Okay. So on the bottom, the one that kind of looks like a flag, those curves, no thank you. And then right above that one, you'll see that one has, most of it's good, but then there's a curved side. Okay, are we done or what do you think? Okay, over here, this one, now this actually could be 2 polygons that are just happen to share a point, but as one figure, this is not good. The one that kind of looks like an hourglass because you cannot have overlap. Okay, so we crossed out all the ones that are not polygons. Now here's the question. The ones that look like this. Is that a polygon? Well, it's closed, straight lined, everything looks good. It just looks kind of weird. Kind of like it's dented or something, right? Now, we're going to go over what that means, but that's concave. Okay? So right now, everything's good. Everything's good. So let's go ahead and think about the next page. You can flip it over. On the back, number 3, it says, in a complete sentence, define the word diagonal. Okay. Now it says to draw them on the other side. We're going to maybe not do that. Well, I want to show you a picture of what diagonals look like. Okay. Now, see if I can draw on here. Nope. How do Okay. So a diagonal is when you go from one corner to another corner and you just connect it. Okay, I don't know if y'all can see that in the blue shape. I drew a red diagonal. Okay, so let's go ahead and try to write this out as a sentence. Okay, a diagonal is a segment that connects to non-adjacent is the word. Vertices. Do y'all know what a vertex is? A vertex is a corner of a shape. So two non-adjacent vertices are not next to each other. So like, let me give you an example here. I'm going to draw like a pentagon. If I connect one vertex to another vertex that's not right next to it, that is a diagonal. I cannot draw a straight line to save myself right now. Okay, it's kind of a, oh my gosh. There we go. So there's an example of a diagonal. I take one corner to another corner, connect it. Cool? Now, concave and convex. Now, if you look at the picture of the slideshow on the right side, look at the concave ones. Okay? It's in the name. Concave looks like it caves in at one of the corners. Okay? So look right here. The one that looks kind of like a health cross, little plus sign, whatever. Do you see how this diagonal is outside? Like if I connect this corner to this corner, it's outside of the figure. If you can connect two diagonals outside of your polygon, that's concave. Another way to think about it is, and I'm going to draw a point here. This point right here, this vertex, is pointing inward. It's caving inward. So it's concave. Look at the one below it. Right here, this vertex is facing inward. It's pointing inward. Same thing right here, right here, right here. All those vertices are caved in, pointing inward. Does everyone understand that concave caves in? Okay? But convex just means it does not cave in. So if you look at all these darker blue ones, all the vertices are pointing outward, no cave in. Okay? Let's go ahead and write this down. Concave means one or more vertex caves in. Concave means one or more vertex caves in. So I draw a little picture. All right. So convex means no vertices cave in. And it's just like a regular looking shape with no caved in corners, okay? So I've said it, and I'll say it again. For those of you who may not have been listening, concave caves in. Very important. All right. Now, next one. Regular and irregular, okay? Now, y'all tell, what do you think? Is regular, if I say, man, you're regular, is that good or bad? No one's answering me. So let me try. Hey, you're regular. Is that good or bad? Good. All right. Hey, you're regular. Is that good or bad? Y'all need to be shooting higher in life. You know, you don't want to be regular. You want to be super number one. Irregular in a good way, you know, because I'm too good. All right, well, anyways. Now, but in math, regular just means everything's perfect, okay? So in this case, regular is like the best. You know what I'm saying? Aesthetically speaking, visually speaking, okay? So regular looks like this slide. All the sides are the same. All the angles are the same. That's regular. Nothing's different. Irregular, it's going to be like lopsided, stretched out, different sides, different angles, which is fine. Okay? We don't discriminate against other polygons, but we just have a category for regular and irregular. Okay? So let's write this down. Regular means all sides and angles are congruent. Okay, irregular means, sorry, my handwriting is not very good on this. It means no sides or angles are congruent. Wait. Let me back that up. Okay, means some sides and angles are not congruent. I don't want to say every side and angle has to be different, you know. Some of them are not the same, okay? Just basically it's not all the same, okay? So regular means all sides and angles are congruent. Irregular means some sides and angles are not congruent. Cool? And you can start filling out the bottom. I bet you know how to name some of these. I bet you know most of these at the bottom. What do you call a three-sided figure? What do you call a four-sided figure? Can y'all write that down? Try to fill it out. All right, what do we call a three-sided figure? Triangle. Thank you so much. I appreciate you trying. That's the angle I like to see. All right, next one. What do you call a four-sided figure? Square is true. A square is a four-sided figure. You're right. However, what do we call all four-sided figures? A square is a specific version. So it starts with a Q. I don't know if y'all can see it because it's kind of dark right here. Okay. Four-sided figure is called a quadrilateral. Have y'all heard that before? And maybe you heard of quads. Okay. But anyways, quadrilateral. So a square is a quadrilateral. A rectangle is a quadrilateral. Trapezoid, kite, etc. Okay. So quadrilateral What about five-sided figure? There's a government building that's five-sided. What's it called? Do y'all know? Pentagon. Y'all ever heard of the Pentagon? Pentagon. Okay. How can you remember Pentagon is 5? Well, some super edgy, cool kids like to wear pentagrams, which is a star, which is 5. I don't want to say sided, but it's 5 vertices on the outside. So anyways, penta means 5. Pentagon, 5-sided, pentagon, 5. Okay, now 6. What do y'all think? What's a 6-sided figure called? No one. Okay, so 6 has an X. Hex has an X. Okay, so hexagon is 6-sided. The way I remember is 6 and hex have an X. Hex, 6. Okay, now 7, I have no fancy way of remembering this, but I'll be impressed. Does anyone know what a 7-sided figure is called? It is called, and I should be moving over here, okay? It is called a heptagon. Hept. No idea why, so just try to remember that. Heptagon, weird one. 7, heptagon, 7. 8-sided figure, like a stop sign. What do we call it? Starts with an O. It's where some of y'all want to catch me. Just kidding. But the octagon, okay? Famous for MMA and stopping at a stop sign. Okay. And hopefully you can remember that. Hopefully you know an octopus has 8 tentacles, octagon, 8 sides. Okay. Now 9, if you never knew this, it's because it was none of your business. That was good, right? All right, so nonagon is a 9-sided figure. It's kind of easy. 9, 9. Nineagon, nonagon. Okay? Sound good? All right, what do you think a 10-sided figure is called? Quick. 10, okay? What do you call 10 years? A decade. So guess what this is called? It's a decagon. Like you're going to deck someone. Decagon. You know, people talk about my favorite decade was the 90s or whatever. Okay, 10 years, 10 sides. Decagon, 10 sides. Now these next two are weird. Okay? But if you know a little tiny bit of Espanol, it might help you. Okay? So, 11 and 12. Okay? 11 is un decagon. It's uno more than a decagon. 11. Okay? So, un decagon. Let's write that down. I'm stuck on this cable. There we go. There we go. Un decagon. Write that down. Now, if you were to Google this, it would tell you it's a hen decagon, like a chicken, which is kind of weird. Both of them work. Un decagon. And then for 12, it's dodecagon. I think of it, it's dos more than a decagon. Dodecagon. Well, there's no S in there, so kind of doesn't work. But whatever, okay? Now, I want y'all to actually know these. So the hardest thing about knowing this is 7, it's like, what is that? Heptagon, whatever. You might, you know, I think octagon, not 9, kind of easy. Hex has an X, like 6. Pentagon, hopefully you knew that. Just remember, decade, un decagon, dodecagon. Oh, why did I write decade? Everybody, make sure you wrote decagon right here. I was writing what I was thinking and not what I was saying. My bad. Okay. Now, last part. I should have been showing you the slide too. Okay. Last part here. Any polygon that does not have a proper name can be referred to as an n-gon. So here's what I mean. Going right over here. N-gon. So what do I call a 13-sided figure? 13-gon. What do I call a 15-sided figure? 15-gon. at some point you just stop using words and start using numbers, okay? So what do I call a 37-sided figure? A 37gon. You get the idea? A 100-sided figure? 100gon. Technically there's names for all of them, but we're going to just chill out after 12. 13gon, 14gon, 15gon, okay? Sorry, let me move that down here. The last thing. Oh my gosh. I just want to move down. Thank you. Okay. The last thing on the slides over here. When you name a polygon, okay, you have to do it in order, okay? So look at this picture, okay? You can call this one on the left A, B, C, D, E, F. You see how you're going along the edge? That works, okay? You could even start at a different letter. You can start at F. F, A, B, C, D, E. That works. You can start somewhere else. C, D, E, F, A, B. That works, okay? But look right here. Look at the nose. Why is A, C, D, E, F, B wrong? Well, you're skipping randomly around the edges. So when you name a polygon, don't be random. Go along the edges. And it's probably best just an alphabetical order if you can. If you can, okay? So that's just when we get to that, when you name a polygon, go along the edges. Don't skip around and do weird stuff, okay? So hold on to these notes. We'll work on something tomorrow using this, okay? I'm going to talk to some of y'all about grades and what our plan is for the fourth 9 weeks, okay? Here we go.